So obviously I'm not in class today because I have a sick child and I have to be at home. But yes, we still have the test tomorrow. And right now I'm going to be going through all the problems which you would have saw today anyways if I was in class. I'm just going to be doing them for you. So follow along. I would see the problem first, push pause to see if you get the same answer as I do. And I will be writing different answers if you could be representing the same answer in more than one way. So here's my problem. The first thing I'm going to do is write my 36 and my 9 in prime factorization. So my prime factorization for 36 would be 3 squared times 2 squared. I still have my y to the 7th. The prime factorization for 9 would be 3 squared. I'm also going to write this as a fraction exponent. Remember, as a fraction exponent means if I have a radical, if there's no number, it's like a little 2 here. If I want to change that to a fraction, it would be like 1/2. So another way to think of it is taking the reciprocal of the index. So now I have a power to a power, and what I have to do when I have a power to a power, I have to multiply the exponents. So I'm going to multiply all my exponents on the inside. So what I have here is 3 to the first times 2 to the first times y to the 7/2 times 3 to the first times y to the 1/2 times x squared. Then, when I simplify, I look for the same bases. My 3's are the same base. They completely cancel because they have the same exponent. My 2 base doesn't have anything to cancel out with. My y's, I have more y's on top, so my y's are going to remain on top, and then I have to subtract my exponents. 7/2 minus 1/2 would give me 6/2, which is the same thing as 3. And my x stays on bottoms. Right here, this would be my final answer. This problem starts out the same way. Should make sure to write it as a fraction exponent and prime factorization and solve. So again, fraction exponent would be 1/2 because my index here would be 2. The reciprocal of 2 is 1/2. And power to a power you multiply. So if I multiply that in, that right there would be my final answer. Look at the problem, write it down. Same thing as the other problems. Write this in prime factorization and fraction exponent first. So if you look here, my index is a 3, so the reciprocal of 3 is 1/3. That's my fraction exponent. You want to make sure to write this in prime factorization because, again, here I have a power to a power, so I'm multiplying. The first one becomes 2 to the first. You can write the 1. You don't have to write the 1. Times 3 to the 1/3. You cannot combine those because you have this fraction exponent. You cannot combine with a base if you have the fraction exponent. X would be 13/3. I can't simplify that fraction, so it's going to stay like that. And y would be 12/3, or else the same thing as 2 to the 4th. There's my final answer. Write it down. Fraction exponents, prime factorization. If you haven't noticed yet, this test is just basically knowing your properties of your exponents. Power to a power you multiply, so you have 13, y to the 8th. A lot of the problems are dealing with your properties of exponents. Write it down. Prime factorization and fraction exponent. I'm going to show you 2 different ways to solve this. Here again, fraction exponent, and if I multiply that in, I have 5 to the 1/2 times 2 to the 1/2 times 5 to the 1/2. Now these two have the same base, so I can combine my exponents. So I have to add. When it's multiplying with the same base, you're adding. So one of my answers could be 5 to the first times 2 to the 1/2. I would accept that answer. The other way that you could solve this problem is square root of 10 times square root of 5 is going to give you the square root of 50. If I do my prime factorization, or if you think 2 numbers that multiply to get 50, I could say the square root of 25 and the square root of 2 to break it up. Square root of 25 is 5. I can't do anything with the square root of 2. I would also accept this answer right here. Both of these would receive 100%. Write it down, then push pause to solve yourself and check it with mine. Fraction exponent, prime factorization, go. Then when you look here, you have a power to a power. Power to a power you want to multiply. So you have to multiply to everyone on the inside. This becomes 2 to the first. this becomes x to the 1/2. Again, if you're not good at multiplying, use your calculator to multiply fractions for you. But I do want it in fraction format. An example, I do not want that written as 1 1/4. Now if I look here, these have the same base, so I can combine those. I still have my 2 to the first times 5 to the 1/4, and I add 1/2 plus 5/4, going to give me 7/4, and this would be my final. Have you noticed my first 2 steps every single time so far? It's been the same thing. Fraction exponent prime factorization. Go. I got that far, but then what do? Oh, I have to use that property. That property with exponents when you're multiplying, when you have a power to a power, basically you're distributing your exponent in, so it's multiplying. My answer would be 2 to the 5/3 power. Again, if you're not good at multiplying with fractions, then put into your calculator. Final. Here's the problem. Can you guess my first step? You're right. Fraction exponent prime factorization. We got that far, and now what should I do with these exponents? Power to a power, I should multiply them. So distribute that power on the side. Remember, if there's no number, it's like 1. So I can get that far, but then what do? Well, if I have division, I have to ask myself first, where do I have more? Well, 3 and the 2, they're not the same base, so they're going to say exactly where they are. However, the x's, if I look at my x's, I have more on bottom, so I have to keep my x on bottom. Then I should subtract my exponents. So 3 minus 4/3 will give me 5/3 if I subtract 3 minus 4/3. And then I have more y's on top, so the y's should remain on top. 1 minus 1/3 is 2/3. This right here is my final answer. There is 2 different ways that you can solve this problem. Attempt to solve the problem by yourself right now, and I will show you the 2 ways to solve it. So your 2 options that you have here is to change your fraction or your radical to a fraction exponent in prime factorization, distribute the exponent in, and then the 2's cancel out, and that's what I have left. Second way you could do this is you can rewrite it as 1 full square root, then simplify 162 divided by 2. That's where I get the 81. Then put the column both top and bottom. These 2 are the exact same answer, just written in a different format. So I'd accept either answer here. Oh my gosh, stop what you're doing. This says adding and subtracting on it. Whenever I have adding, subtracting, like I do here, here's subtraction, here's adding, I have to simplify each radical first, so you're not changing it into an exponent. You're simplify your radicals. That's what you should do right now. Pause the video. So if you simplify this, looking for your perfect squares within the factor. Now I already had someone in one class say, you should look at this last one. If it's prime, that's what you should try to divide each of your other numbers by, because they'll probably end up to be a square root 3. So if I simplify this would be like 2 times 4, because the square root of 16 is 4. That would give me an 8 square root 3. This would be like a 3 times 2, so it would be minus 6 square root 3. And then I still have my 4 square root 3 on top. Now all of these are square root 3's. So that means I can look at the coefficient, the number in front. 8 minus 6 is 2, plus 4 would give me 6 square root 3. And that right there is my final answer. Again, adding and subtracting, adding and subtracting. If I'm adding and subtracting, that means I'm probably going to leave my numbers as radicals as such. And this is multiplying in between, so I'm going to do FOILing. So I have my first here, 3 times -5 is going to give me negative 15. I have my outside, the 3 and the 2, they're the same, so that's what you multiply together. So I have a negative 6 square root 7. I have my inside here, the 4 and the 5 are alike, so that's what you multiply together. That's where I get the negative 20 square root 7. And then my last, again, if you're not good at multiplying this, then I would do this in your calculator. The two numbers you're actually multiplying together are these right here, because that's my first times my last. 4 times negative 2 is going to give you a negative 8. Square root 7 times square root 7 is going to give you a 7. So negative 8 times 7 will give me a negative 56. When you're doing this, your first and your last should be combined, and your two middle terms should combine. So negative 56 minus 15 is going to give you a negative 71. And negative 6, because that's my leading coefficient, minus 20 will give me a negative 26 square root 7. Do not combine those because I have the square root 7. I cannot combine those together at all. This right here is my final answer. Oh my gosh, looky here. Here's an adding. So I'm probably going to leave my number as a radical. I have to rationalize this. I don't want this right here. I do not want that right there whatsoever. So I have to multiply by something. And since this is adding here, I can't do it by the exact same thing in the denominator. What I have to do is multiply by the conjugate. Remember, the conjugate is always the same two numbers, so I still have my 2 and my square root of 3. However, it's close to the same, but not exactly. If this is adding, I have to make sure to have the opposite symbol in between here. So now when I simplify this, I have to distribute the 7 in. So this is going to give me 14 minus 7 square root 3. And on the bottom, I have to FOIL. I have my first 2 times 2, my outside 2 times negative square root 3, inside 2 times positive square root 3, and my last negative square root 3 times square root 3 is just going to give me 3. So then when I combine my like terms, again, my first and my last, if for some reason your middle terms don't cancel out, go check it again because something went wrong. I still have my 14 minus 7 square root 3 on top. And then if I have 4 minus 3, that's just going to give me 1. I could leave my answer like this, or you could just write this as your answer. Both of those are the same shebang. Oh, looky who says the hooky. Again, I'm going to multiply. Oh, multiply, I'm going back to my roots, my properties of exponents. These already have the same base. If they have the same base and it's multiplying, then that means I have to add exponents. So again, if you wrote this out the long way, this is what it would look like. So I just have one base here, and 1/4 plus 3/8 is going to give you 5/8, and this right here is my final answer. Oh, look. Again, I'm multiplying, so I'm using my properties. Oh, darn it. These two are not the same base. That cannot happen. I cannot add those exponents. However, what I can do is rewrite 21 as 11 squared. Look at that. Now I have this power to a power, so I can multiply those two powers together. I get 11 to the 2/3. Oh, now it's like the previous problem. They have the same base, and it's multiplying. So I can add my two exponents together, and I have 11 to the 4/3 would be my final answer. Look at this one. Hey, remember when I said prime factorization, fraction exponent? Well, half the work's already done for us because we already have our fraction exponent. So you should always rewrite in prime factorization. So if you don't know what to do, you should take your 64 and have your factor tree. Otherwise, I have memorized that 2 to the 6 is equal to 64. So now I rewrite that. Now I have a power to a power. Power to a power, I should multiply. So I have 2 to the 6/4, and I have a to the negative 6. I do not like green eggs and ham, but I also do not want negative exponents. So my final answer here would be 2. You should always simplify your fractions if you can. So this would be to the 3/2 power over a to the 6th. There is my final answer. What should I do with this problem? Well, I'll tell you. I want you to write this in a radical format. So meaning, here's already the fraction exponent, but I want you to rewrite it so it has a radical with it. So remember, the fraction exponent is always the index number, so that 3 is going to go on top, and they still have x to the 7th inside the radical. So right here's my final. Oh, I already got my prime factorization. I already have my exponents set, so that means I am just going to have to have my power to a power. Remember to give it to everyone on the inside. So this would be x to the negative 20 over 2 to the negative 4. I do not want negative exponents. If it's negative on top, I have to move it to the bottom. Once I move it, it becomes positive. If it's negative on the bottom, I have to move it to the top. Can you tell that my Mountain Dew is kicking in? This right here would be my final answer. You could have also had this written as 16 over x to the 20th. I would accept that answer as well. For this problem, I'm not going to write it in prime factorization. But how? But how do you know, Ms. Rickman? How do you know when to write it in prime factorization? How do you don't? Well, in this problem, I'm not having a power to a power. You should always have prime factorization when you have a power to a power. In this case, I don't. And in this case, since I do not have any fraction exponents, this would be like to the first power and this would be the first power, I can multiply these two together. So I can do 6 times 5 would give me 30. And my x's, they're being multiplied together as well. So I could rewrite my x's to look like 1/4 plus 2/5 because that's, when you have the same base, you have to add your exponents. So then I would have x to the 13/20. You could have this as your answer. I also would not care if you had 3 times 2 times 5, x to the 13/20. Either of these answers would be acceptable. No prime factorization. This is just your basic property of a power to a power you should multiply. So I would have x, if I do 2/3 times negative 18, that would give me a negative 12. If I have 5/6 times a negative 18, that would give me negative 15. Eek, I don't want negative exponents, so I have to bring them to the bottom. Let's bring those to the bottom. But if I just write them like this, that doesn't really mean that they're on the bottom. So I have to make it a fraction. So this right here would be my final answer. And that is all I have for you for today. Have a wonderful day, and I'm looking forward to be grading all of these A tests tomorrow.